Hey, good morning, folks. It's great to see you today. Um, yeah, happy to be here with you. Hopefully, week one went really well for you. I really apologize about Schoology, the equation editor, things like that. I'll find other ways to get homework to you if need be. I just want you to know that I've received different forms of submission of homework from people, and I really just want you to do what works best for you. So some people have just, you've been, writing down your answers in a normal workbook and then you're taking a picture of it sending to me, that is just fine. Again, I want you to do what works best for you. So I've been able to see those. Some people have taken a little bit better pictures and maybe have a little bit better handwriting. Anyway, which you could help me out there would be great. But I've been able to work through your stuff so far. You guys have been doing a great job. Hopefully, posting answers the way that I have helps you out to make sure you're doing it correctly. I have been able to Google Meet with a number of people and it's been a helpful process. I really enjoy it. Please don't be afraid to reach out and say, "Hey, Mr. Yancz, can we go over this problem together?" And we'll take you through that. So we're going to break this week up into two sections. We're going to move on to volume by washers, and after that, we have one more section. Next week will be volume by cylindrical shells, and then we'll get ready to review and test. And trust me, if you've been following what you're supposed to be doing for your homework, you're going to do just fine on the test. So trust me there. Okay. So let's look at the type of problem that we want to see today. We're going to look at y equals x squared. Call that guy example one. And y equals 9. And we're going to say and x equals 0. The area that is enclosed by those three revolved around the x-axis. So the question is, what is the volume of that region, that shaded region, when we revolve it around the x-axis? So if we draw a picture of this, there's my x squared. There's my y equals 9. And if we take this shaded region and we revolve it, what's going to be different is, this region right here, not this region, but this region, as we revolve that, we're going to end up with this gap right in the middle. So if I can try to draw for you what this region looks like, I know it's challenging for people to see, but I'm going to do my best here to draw it when we revolve it. I'm going to take a rectangle from the area, and when I revolve that rectangle around, that's the shape that I get. I get a washer. And the volume of a washer, we could definitely find. It's not that big of a deal. I'm going to draw it out specifically over here. Once I understand that I get a washer, sometimes I like to put my work right over here to work on it. Yeah, the way that we find the volume of a washer is, first of all, we look at that thickness, and in this situation, we have width of dx. Okay, so it's horizontal width, and then we try to find the area of the rest of the shape and multiply those together. Well, if we call this big R and we call this smaller region here little r, what we could do is we could take big R squared times pi. That's going to be the area of that the entire circle, and then we subtract off the area of the smaller circle. So minus pi times little r squared. And that's going to be the area of a washer. And maybe you remember that a little bit from geometry, but that's our formula. And in this case, we look at what makes up this top line right here. This top line right there is made up of pi. Y is equal to 9. So that's my larger radius. What makes up this smaller inner part here? Well, that would be x squared. Y is equal to x squared. So when you work this out, and we can factor out the pi out of this, so pi times big R squared minus little r squared. So in this situation, we have pi times big radius is 9 squared minus little radius, which is x squared, or x to the 4, dx for our width. And that's the volume of one of the washers. We would like to do an infinite number of washers, and so we slap an integral symbol in place, and we integrate. If you look back at your original area, this is our original area, we integrate our x values. So we started here at 0, and we're going to go all the way over to, well, if this is 9 and this is x squared, what is the x value here? The x value is 3. And now we can go through our integration process. So we have pi times the integral of 81 minus x to the 4th dx, evaluated from 0 to 3. The antiderivative of 81 is 81x minus antiderivative of x to the 4th is x to the 5th over 5. Multiply that all by pi. Evaluate 3 and it's 0. 81 times 3 is 243. Minus 3 to the 5th is 243 over 5. Yeah, it looks like I'm actually going to have to do this. I don't have my calculator around. So we're just going to go 243 times 5, 15, carry the 1, 21, 10, 12, 2,115. So pi times 2,115, or 1,215, over 5, minus 243 over 5. And 1,215 minus 243, good old subtraction here, 1, 7, 1, 0, 1, I got 972. 972 pi over 5. And that's our result. So you look back at the problem from where we began and where we are now, it's pretty cool to be able to see the whole thing. So yeah, we are 9 minutes in. So these problems take a little bit longer. I do want you to watch another one. So I'm going to go ahead and stop this so we don't run out of time. The videos that I'm making, you can only make up to 15 minutes worth. So I have to pause every once in a while. We're at 9 minutes right now. So we'll do one more, and then you'll be able to start a couple of problems from here, okay?